Hello and welcome. My name is Gerhard and I'm a data scientist and book author at SAS. In a previous data science webinar, I have shown the importance to calculate individual reference values when you want to check your actual value, whether it's above a certain limit or not. Today, I would like to take the same topic. However, I would like to show you how you can use self-service analytics in order to calculate and visualize these reference values on your own. And I will show and explain this how you can use SAS Viya to do so. The case study that I showed in the previous webinar, and which I'm also using today as a basic example, is that it's important to provide reference values which is not one size fits all, but considers all available information which can make the reference value more fair or more representative. This means that providing such reference values also reduces the yes but sentences from business, because when they say yes, this is an outlier, but on Friday we always have lower values or lower visit frequencies, or yes but in December we always see different patterns from our customers in transaction numbers. This is what we're going to do here, and I would like to show you how you can do this with SAS Visual Analytics. The picture that I was using in my previous webinar is the following one. So you see that the reference lines, the overall limit, if you just use a straight line as this one, you are at risk that you consider certain observations at outliers which are still within the limits. For example, here the blue ones. Or you might ignore certain outliers because they do not exceed the overall limit, but which are much further away from the individual limits, and they are most likely outliers which you do not see. So the webinar today is to show you how can you calculate these individual reference lines automatically and how to visualize them with SAS Viya and SAS Visual Analytics. This method is very important. So you can apply it, for example, in data quality checks. In data quality checks, very often the question comes up, is a certain value an outlier which need to be manually checked or which should be rejected by the application? And if you just have a one size fits all comparison limit, you might have maybe too many events which you check which are not relevant, and you might ignore some other values which are outliers and you don't see them. So data quality checks is a very important example for that. Another example is fraud and anomaly detection. So the question whether a certain value is suspicious, is far away from what you expected, should not be done on a one size fits all example, but should be based on very individual, very fair reference values, because you only want to investigate those cases which are really far away from what you expect, and use your resources for checking and for comparison to the most relevant cases. In my SAS Press book, Data Quality for Analytics Using SAS, I'm showing how methods of data science and analytics can be used to profile and to improve the data quality of the data. So if you would like to see more and also learn what requirements analytical methods have on data quality, this is a very good address to go to and take a look at that. So today we are going to take a look at how you can perform these calculations with self-service analytics. I'm going to show you how you can use SAS Viya to perform this analysis and this visualization just by using a graphical user interface. The case study that we are taking a look at is based on example data and an example case based on the used car value. So the question is, are the quoted used car values or the blue book value, are they fair, and why do they differ substantially between cars? Which deviations are acceptable and which deviations are just triggered by car type, different age of the car, and different driving distance. So we would like to calculate now reference values in order to make sure that if we highlight some values which are far away from their peer group, by calculating them based on other variables and not just using a one-size-fits-all reference value, and to consider the values of peer values to be more fair and to be more objective. So the point is that we are doing that we're considering here is answering the question: does one limit fit for our purpose, or can we do better? And yes, we can do better. We now move into SAS Visual Analytics. In SAS Visual Analytics, I have the chance to analyze data that I can load either from the cloud that I have available here, or I can also load local data that I have on my laptop. In this case, I have already loaded the data from my SAS database, and I have, for example, now variables available like car type, car use, the blue book value, the policy number, and a couple of others. You also see I have already created some derived variables. However, I will go in this example and explain how I did this. Another important component in SAS Visual Analytics is the objects that you can create. So for example, you can create descriptive statistics with crosstabs and list tables, and then you see that you can create a large number of graphs in order to visualize your data, and you can also perform analytics and statistics using certain methods. This is all what we are going to show and what we are going to present here in this analysis. However, let's first take a look on the data that I have here available. You see I have a column policy number, I have, as already mentioned, the value of blue book, and we see that the blue book value differs a lot between the values. We will now see how can we run a simple analysis just on the blue book value, and we will then go in detail our analysis by considering also car type, car use, the travel time, so which is a one-to-one relationship, like how many miles or how many kilometers does the car already have, and also the age of the car in months. This is what we're going to do. Let's now take a look on a first descriptive analysis, how we can analyze the location measures of our data. What you see here, that I provided a very simple table where I have the mean of the blue book value. It is on average $15,660, and the standard deviation is 8,428. We also see a box plot that I automatically already created here, which shows us that the blue book values range from very low values to quite high values around the 80,000. However, most values are located somewhere between 10 and 20,000, and this is where 50% of the values are located in. I can now easily go and extend this analysis, for example, by just going into our data and saying, I would also like to add the blue book, for example, as an histogram. And I just drag and drop the variable blue book here. It says auto chart, meaning it will decide now based on the selected variables which chart is most appropriate. In this case, he decides for a numeric variable. The histogram might be most appropriate. However, we could also go here and change this to any other graph type if we want, or we could have pre-specified a graph type by just creating this graph type on the data. So we already now have a short dashboard where we see what is the distribution of our data, what is the mean, what is the standard deviation of the data, and we see that there's quite some difference. There are low values and high values, and maybe values above a certain value, maybe something like the blue book value plus 3 times the standard deviation, which is a value of 40,945. This could be considered as outliers, so maybe something like here, this could be considered as outliers. So let's go and take a look how we can check this in a scatter plot. And move further and take a look on our scatter plot here. You see that I have already created such a scatter plot that I would like to create to compare the values which are inside the limits and which are outside the limits here. However, you might say, okay, this is all predefined. How can I do this on my own? So I would like to quickly show you how you can create a scatter plot on your own and then show you how I parameterize them and how I change the colors here. So from the objects, I just went down and said, okay, a scatter plot makes sense here, and I just add here a second one. Next, you go and say assign data. For example, as the measures, you might say on the horizontal axis, we just use the sequence ID, and on the vertical axis, we use the blue book value. If we do so, we see we automatically get a scatter plot assigned here as we do. And we can now go and say here we would like to add also a group variable in order to have the colors displayed, and for example use this as the global variable that I prepared up front. So you see this is all already here. However, for better visualization, I changed the colors, those who are inside the limits, I changed them to green. Those are outside, I changed them to red. This is very easy to achieve. So you just go here on the scatter plot and you say you can go and change the marker colors. So for example, those who are in blue, we would like to change them to red. And those who are here in gold, we would like to change them to green. So we see that we gain the same output very easily. And what I did here on the right side is just adding under options. I just went here and also added a reference line, so you can always add reference line as many as you want and say I would like to label this as the free sigma limit, and the value is 40,945. This is the mean plus 3 times the average that we previously calculated. So you see, very easy to achieve. And I quickly delete this the second example so that it's easier for us to review the data here. Maybe you would now like to find out how did I calculate this exceed global sigma variable automatically, which determines whether the value is inside or outside the values. I would like to show you this how I did this here on the data tab. I went here and created a new calculated variable. So you would just go and say, I would like to add a calculated item. And in this calculated item that I already created here, my exceed the global sigma limit, let's go and add it to show you what I did. So I did here just a simple if then else clause, and you have the option either you know the syntax, you can program it here with if statements, returns, and so on. Or if you do not like to program them, you find all the clauses that you can and that you want to use here. For example, the if then else clause, the calculation clauses, the comparison clauses, all is available here. So you just drag and drop them here to automatically get the syntax. So what I said is, if the blue book value is larger than 3 times the standard deviation added to the mean, so if it exceeds this, I return X for exceeded, otherwise I return in for inside. So very simple creation of a binary variable, inside and external, based on a simple condition that I just created here by point and click, and the values that I inserted here are the values that I calculated earlier. As I have this variable, this allows me to use them as a group variable here, and allows me also to simply add them here as a color variable, and to display which variables are outside and which variables are inside. The question now, however, is, are we doing a fair analysis here? Because we just say we are using a one-size-fits-all limit and say all the values that are beyond this limit are considered to be outliers. They should be checked. They are maybe too expensive values for the cars, and all the values who are inside here, they are considered not to be this. As we already saw earlier, there might be reasons why some cars have a higher price and have a lower price, and let's now take a look on how we can analyze and how we can compare this. Let's go back to our analysis that we created earlier, and we see that we have here the Blue Book mean and the Blue Book standard deviation. So what happens if we would now like to subgroup this analysis, for example, in the rows for car type? Maybe some car types per definition are more expensive, others are less expensive. So if we add here variable car type, we see that the total of 15,000 is quite different based on different car types. So the vans are more expensive, also the panel trucks, and others like the pickups and the SUVs are less expensive than the average. So we see that it makes sense to base our reference values not just on the average, on the 15,000, but better individualize them on the group individual average values. We could now do this manually for all the variables that we have available, and could go and create manually a chart like we have it here based on the subgroups. As SAS Visual Analytics, however, not only offers descriptive statistics as we saw earlier, but also methods of statistical analysis, I would like to show you an easier and more performant way to do this. In order to do so, let's go and add a new page to our analysis and say we would now like to use an analytical object, for example, a linear regression. A linear regression allows us to consider the influence of input variables like car type, age of the car in months, on the Blue Book value, and calculate reference values or expected values that consider these by groups and this available information. So let's drag and drop the linear regression object here on the new analysis. So we receive an empty template, and it now asks us what it should do. We say the response variable is the Blue Book variable. This is what we would like to analyze. And we say, do you have classification variables? We say, yes, we have two classification variables, namely car type and car use. We add them. And we also add continuous variables like the car age in month and the travel time, which is an equivalent to the kilometers or miles that the car has already. So adding these variables now leads to the fact that it automatically builds an analytical model. Analytical model means it analyzes the 4 available variables on Blue Book by using car type, car age in months, travel time, and car use, and says it tries to fit a regression formula, which we can see here under parameter estimates, and we see that it says the panel truck have on average higher values compared to the pickups here, which have lower values, and also like the sedans and sports cars. So it calculates individual reference values based on the car type and maybe also for the commercial and private car usage. And it also calculates for each month, for each additional month of the car, how much does the Blue Book value change and how much does the Blue Book value change based on the kilometers. So this is a method which can be easily achieved here also in SAS Visual Analytics just by dragging and dropping the analysis, and we can see which variables make sense to have in our analysis in order to calculate individual reference values. So this is what I did here, and have here a first simple model that I created here. Maybe we would like to change the statistics to R square, which is easier for us to understand. So it now says 32% of the variation is explained by our model. that might make sense, because not every individual Blue Book value can be explained just by these 4 variables, but we already have quite a meaningful model. Having the model now is one thing. However, we would also like to go one step further and say we would like to derive the values that we created here. So now for every Blue Book, for every car, we have an actual Blue Book value and we have a predicted Blue Book value by the model. So what we can do now is we can say we would like to derive these predicted values from this model. So we can go and say this would be Blue Book predicted by model as a new variable, and export this variable. You see that after I do so, when I go back to the data, we see that we now created a new model, a linear regression, which says Blue Book predicted by the model, and we now have an individual reference value. This individual reference value not only considers the average per car type, but also considers the value per age in month, per distance in kilometers, and acts like a more individual, most likely also more fair reference value for our data. So you see that after running such a regression analysis, which we did here together in this case, or in a regression analysis in the same one that I prepared earlier, we get new variables into our data and have the chance to have these predicted values as individual reference values created automatically without writing a single line of code, just by pointing and clicking here in the tool and getting additional variables now in the data. Let's take a brief look what the values mean that we see here, and I go and add, in order to visualize this for you, I go and add a list table, and in this list table I go and add, for example, I add the policy number, I add the car type, I add the car age in month, and I add the actual Blue Book value, and I also add the Blue Book value which we now created by our model. If we do so, we want to not only to see the aggregation of this data, but also the detailed data. So we learn that for certain cars we have an actual Blue Book value of 14,000. However, the predicted or the expected value would be here 16,200. For this car, for example, for this van, the actual value is 21,000. Expected by the model would also be 21,000. So we get individually, based on the variable for each car, now individual reference values, and this makes for us much easier to compare now whether a certain car is far beyond its expected value or not, and run our analysis in a much more individual way. Let's take a look how we can use this and how we can visualize this. In order to do so, let's take a look on our available data. As I said earlier, I also ran a linear regression, the same as we did already earlier, and I derived here also the predicted value, and I called it reference value to have a very a variable name which is easy to remember. In the next step, I added a new variable which I called individual upper limit. So different to the one-size-fits-all limit, I now calculated for every individual variable an individual upper limit. Let's take a look on which values that I used here. So I just said here I used the reference value, so the individual one which we calculated by our regression analysis, and added to each reference value 3 times the standard deviation. So what I now get is an individual comparison value for each individual car based on its reference value plus the standard deviation. I can now use this reference value and the individual calculated upper limit to calculate more individual analysis. So for example, let's take a look here on a step line chart. What did I add to the step line chart? So the step line chart is a very important feature that you have here, for example, by step plots. And I just said at the horizontal axis, I again use the sequence number of my cars, which I added here on the horizontal axis. And on the vertical axis, I added my variable individual upper limit. So you see that I have certain cars where my blue line, the individual upper limit, is lower than the 3 sigma limit which we used in our earlier chart. However, then there are cars where the individual reference limit are higher. So we have cars where the expected average is higher, when we have cars where the expected value is lower. So for our comparison, in order to select, is a car value suspicious? Is it maybe too high? It makes much more sense now to compare against our blue line compared to the straight line here that we used as the sigma variable. And I would now like to show you how you can do this and what options you have here in SAS Visual Analytics. In order now to use the information based on the individual upper limit, we can perform the same as we did earlier. We create a new binary variable which says exceeding the individual 3 sigma limit, and it's very easy to create this as you also saw earlier. I just specified here with the same clauses by using the if then clauses and said if the blue book value is larger than this individual upper limit that we just calculated, return X for exceeded, otherwise return in for inside. Very easy to achieve. So what we have is now 2 binary variables, and if we now go and for example and copy our scatter plot that we just created, so we just need to say we would like to duplicate it and receive this scatter plot again as a copy. However, now under the roles we say from the coloring we would not like to use this global 3 sigma limit, but we would like to use here a different variable, namely the individual 3 sigma. So we see that we now get a similar, but if we look in detail, a different picture. Again, we have, for comparison reasons, our 3 sigma limit, the one size fits all limit. However, now our analysis says there are some values which are lower than the limit. However, they are still suspicious because they exceed an individual 3 sigma limit, even if they're smaller than the overall limit. We have other values which are higher than the actual 3 sigma limit. However, they are still inside because their expected value is not exceeded. In order to visualize this graphically in a simpler way, we can say we would like to add to the data type values also our individual upper limit, because this makes it much easier to compare now, and say if we now move on this point, we see yes, this point here, it has an actual blue book value of 48,000 and its individual upper limit would be 54,000. So even if it's larger than the overall 3 sigma limit, it's still inside the individual upper limit. Compared to this value here, it is inside, however, it is 38,000. However, its individual limit would have been 37,000. So what we achieved here is an individual way to compare our values and flag them whether they are inside and outside. And this is much detailed, much fairer, and much more precise compared to just using a one-size-fits-all line as we have here, because now we compare them to the step line that we showed earlier and are much more individual and much more detailed. In the next step, let's take a look how we can visualize the difference between the global and the individual reference values in a more detailed way in this graph. In order to do so, I created one more derived variable that contains the categories, and I called it exceed global and individual. So in order to show how I did this, let's take a look at this. I just concatenated both variables. So you remember we had in and x of the global reference value, and we had in and x of the individual reference value. We can now go and concatenate, and as I said earlier, you do not have to program this. However, you see here that under text simple you have lots of text functions as well. And if you don't know whether you can find them and say I would like to concatenate something, you find the concatenate function here automatically. So I concatenate my two other indicators that I have, and if we take a look on preview, we see there are now in this new value, we say if it's inside the global 3 sigma and if it's inside the individual 3 sigma, we receive in. Otherwise, we might receive x in x, or xx. This is how we use this. We again go back to our scatter plot that we just created here. We go and duplicate it and run a new analysis and say, for this one, we would like to go to roles, and now go and change the variable that we have here used initially, our individual indicator variable, whether it's inside or outside the individual limit, and go and remove this and add here the variable which we created newly, our exceed global individual variable. After we have this, we see a similar picture, however, with better color codes. So we now see again the green values which are inside the individual limits and inside the over limits, the red ones which are outside that we have here. But in addition, we now see those in orange who are inside the global limits but outside of the individual limit. So for example, this one is the one who is highlighted here, saying its blue book value is 38,800, which is larger than its individual expected value of 37,000. And we have values which are higher here than the overall limit, however still smaller than the individual limit. So we see same analysis but better color code to illustrate the difference of individual and global validation limits. Maybe one quick comment on how I achieved here this color coding. So what I did here under rules I have the chance to predefine colors for certain categories. So what I said is I can now do this, for example, for a certain variable or for all categories. If the value is in, saying in the individual in the global ones, it should be colored green. If it's outside of both, it should be colored red. If it's inside the global but outside the individual, color it orange, and blue for the other categories. So this is a very simple way how you can define color categories which I applied to all your graphs here. So we see what we achieved by running our linear regression analysis here, and having a much better view now on the chart that I created together with you, seeing that we do much better and that we are much more individual if we apply it that way. I can now also go and say I would maybe like to run this analysis and illustrate this not by the sequence ID as they are available in the database, but I would like to reorder them based on their expected blue book values. For that purpose, I have already created a variable that I that I named here not sequence ID, but I renamed it here to sequence reference value. So this is now just a reordering of the values that we have, and we see that our actual values differ here a little bit. We see the higher values more on the right side and the lower values more on the left side, and we also see that we have here the group of those smaller values that we overlooked mostly for the lower cost cars, values which are under the global limit, however which are above the individual limit for the lower cost values, compared to other variables here for the higher cost cars, where values with values higher than the overall limit might still be acceptable, might still be blue colored compared to the others. So we see here, for example, for this one, again, individual blue book, the actual blue book value 48,000, individual upper limit 54,000, compared to this one where it has a smaller individual upper limit which is exceeded by its actual blue book value. So this is just a different way how to show and how to present the results. So what we have learned here is it is important to apply individual reference limits, and it's easy to do so in SAS Visual Analytics because here we can combine the visual capabilities together with the analytical capabilities, for example, like running regression analysis. Before I close, I would just briefly like to show you what I also did here for this analysis. You can also SAS Visual Analytics to expand here an area where I said I would like to use page controls, and in these page controls I can easily add, for example, certain variables, for example the car use, adding it here in addition to that. So I can do so here by just adding this and say, okay, this is now commercial and private, and I can now go and, for example, select here certain groups, and the data is now just being filtered to those which are selected here. So it is filtered to cars of age 6 to 24 months with private usage, and I did not subselect any of the car types. For example, if I would like to subselect on SUV, we see that this is the group of SUVs in private usage which are quite newer cars. So we see this is the cloud of values here which are inside the limits, and these are the values which are outside of the limits. These two should be examined here. So this is just an extension of what we saw earlier. It's very easy just to use this method, for example, to subgroup from our initial screen which we had here with all the data, and say we would like to go and, for example, say we would like to take only a look on cars which are older than 2 years, for example, which are older than 2 years, and which are still younger than for example close to 60 months. So we get this selected. We would like only take a look on panel trucks and panel trucks that are used commercially. So we see here now that we can use this tool also to subgroup and study certain groups in a more individual way. This can be used also to create control lists, for example, where we say we would like to assign a certain checklist to the validation team A, which is going to check the panel trucks. We can easily filter this one, and also discuss results here based on segments, based on regions, based on other criteria. Say, okay, this is what the global model would have been considered as outliers. However, as panel drugs have a higher blue book value on average anyhow, these blue ones are not considered as outliers, only those exceeding a certain value. This one and this one, only these two would be considered as outliers. So same method as before. However, it is easier that way to display and to discuss the data with business experts, where what you have seen here is a very good way to visualize, to calculate, and to interact with the data using a very easy to use user frontend. To wrap up, what I've shown you here, how easy it is using SAS Visual Analytics to reproduce an analysis and a visualization like we saw it here earlier, and how you can create individual validation limits. We performed this task in SAS Visual Analytics by studying our data visually and graphically. Then we created a scatter plot in order to show what is the effect of a global reference value and the global validation limit as we have it here. We then moved one step further and used the available analytic capability in SAS Visual Analytics to run a regression analysis, which gave us the individual expected value. And this individual expected value allowed us to be more precise and not do a one-size-fits-all and have more individual comparison values like we see here with the blue reference line. And this was the way how we were able to show this in a much better way and see that there are values which are inside the global limits, but which might still be values which should be considered compared to the blue values that we see them here, which are outside of the validation limits, but still might be valid values. What you have seen is that analytics and data science can help you to be more individual, to be more objective. So the value that we very easily calculated is a very objective picture and allows us to rank our analysis subject based on their deviation from their peer group and not from the overall mean. This allows us to get much more relevant and much more explicit results, and you've also seen how easy it is to use SAS Visual Analytics to perform this analysis just by point and click under the paradigm of self-service analytics. The example that I presented here is one out of many others that I shared in this webinar series. So today we were looking on providing individual reference values, but I also presented case studies on Monte Carlo simulations, simulating the Monopoly board game, automatically detecting structural changes and outliers in your longitudinal data, performing headcount survival analysis for employee retention, and many others. In the appendix to this presentation and in the notes, you find a lot of links where you can find more content on other webinars, on blogs, and on content that I share in my books or on GitHub.